So, my name is Darren Hague. I'm from SAP. It's a small German startup, been going since about 1972. I'm going to talk about how my team within SAP went from being on a really old infrastructure a few years ago, Java 1.4, places you don't want to go, through our journey over the last couple of years to get to where we are now, where we're pretty much at the cutting edge of doing continuous delivery. If you've got any questions throughout the talk at all, feel free to interrupt me. Interactive is good. What I'm hoping you'll get out of this is some things, get some of the lessons that we learned, things you can take home, allow you to do more continuous delivery in your own work. So first of all, I'm going to talk a little bit about SAP the company, then the bit of SAP I work in, then my project and team, just a few slides just to give you a little bit of background on what I do. So SAP itself, founded, as I say, just over 40 years ago now. Nice vision that the company has, just help the world run better. That seems to be turning into quite a good business model for us. These days, we're doing a lot more innovation. People who know SAP may think of it as a bit of a dinosaur itself, lots of big old mainframe software. But we produce really the software that runs most of the businesses in the world. We've got almost 250,000 customers in most of the countries on the planet, 65,000 employees now. And the core product, this big ERP system that runs HR, accounting, CRM, everything else, it was a real shock to me when I first came across it as a piece of software. I've been used to doing web applications, database backed, you've got a bunch of tables in a schema, and then someone told me this application had a schema with 30,000 tables in it. And it was the first time in my life I'd come across a piece of software that was utterly beyond the scope of one individual to comprehend. So yeah, it's quite an interesting company to work for, given that we're working on a product at that scale. A lot of the modern innovation we're doing is focused on this new database platform called HANA, which you may have heard of. There's a link at the end where you can have a play with it on Amazon. But the idea behind that is now that you can have a database where the whole thing runs in memory. The biggest one we've got has 250 terabytes of RAM. And the idea is that with that amount of RAM, who needs a disk? The disk is what tape used to be used for. It's what backups are for. But all the data runs in memory. 4,000 CPUs gives it a fair turn of speed. And suddenly you don't need a data warehouse anymore. So yeah, very interesting times. So within all of that landscape, I actually don't work on any of that product. I work in the IT department, essentially helping to run the corporate websites. But we're run by a guy called Oliver Bussmann. He's very active on Twitter. He's actually, I think he was nominated most social CIO in the world last year. And he's given us this great policy, which is when it comes to our own company and our own IT department, we have to run our own software. Which is really good for the software itself. We give a load of feedback as a customer of our own software, help improve it. And also it really helps, we must be one of the few IT departments in the world where we actually generate revenue for our company, because we can actually go out and help sell the software. You know, we're our own reference customer. We can actually go to prospective customers and say, well, yeah, we run it too. We know some of the pain points. We can help you through them. So again, it's a successful strategy. So within IT, my team itself, we work on something called the SAP ID Service, which is a little bit like accounts.google.com, that kind of thing. So the idea is, one of the things that our software does as a company is have this principle of there's one version of the truth. So that's why we integrate accounting, HR, and all these other things into one big system. So you're not trying to integrate between things too much. It's all just in one common model. Having said that, until a few years ago, as a company, as a big company, we had multiple websites. We had the core corporate website, sap.com. We have a developer community. We have various custom communities for various things. And what was happening is individual people were having to create multiple accounts on each of these different websites to talk to one company that was trying to sell them the concept of one version of the truth. And that got a little bit embarrassing. So the whole idea behind this project is we can allow people in the business still to build all of their own websites and do different things, but they all talk to our system to actually get the identity of the end user. So all the user does is they log into SAP, and then they can navigate around, and they're much less aware of the fact that there are all these different web applications. And we're actually now starting to expand that to our cloud offering as well. So as other customers and their companies sign on to our cloud, they can begin to use the same system with their customers and adopt the same principle. One of our challenges is at the moment we have, as you see from the bottom of the slide there, about 4 million users today, which is, it's not small, but it's not Facebook scale. We had a few recent acquisitions. We've got a few more million users coming in. And then the CEOs set us this corporate challenge, which is by 2015, which is really not far away now, we need to have 1 billion users, which is, that's tough for the rest of the company, but also particularly in my team, we've suddenly got to make our system scale to a very large number indeed in the next few years. So it's an exciting place to work. And within that, my team itself, we're actually split around the world, and we're a multifunctional team, which is something I'll come back to later. It's a classic thing around continuous delivery. But we have team members primarily in Germany. That's where SAP has its roots. A couple of us in the UK, a couple of guys in Russia, a few guys in Israel. So we do get together a few times a year, but most of our communication is virtual. Lots of conference calls. So we have a lot of experience in working in distributed mode. So that's the background. So as you may have seen from the title, we're going from the Dinosaur Age to the Space Age. The Dinosaur Age, in 2010, we're using Java 1.4 to build many of our web applications. That's 2 years after its end of life. One of the reasons is that because we have this SAP runs SAP philosophy, at the time we were running on our web application server, it was Java EE 1.3 compliant, and we promise our customers that we keep these things running for 10 to 13 years with support. So we were still using that. A lot of us were getting very excited about generics and things, but it was all just dreams to us at the time. Interestingly enough, the company itself produced the first ever J2EE5 compliant system, but it was never really fully released. We actually got the certification, but it never really made out the doors as a product until relatively recently. We were kind of agile-ish. It was a kind of blend of, I'd say it's a rapid waterfall, if you like. So we did have monthly releases, but within each monthly release, it was run very much like a waterfall kind of process. We did have source control, centralized, issue tracking, that was fine, automated build. But on the downside, if we wanted to do a new project, we wanted to order hardware for that to run on, that took months to get a server running, which was kind of silly. To actually deploy a new release of the software onto something like the developer site, that took a good week or so of preparing all the artifacts, sending them to a test server, the test team. They had a few automated tests, but it was mostly manual testing. It took a long time, a lot of fire drills as a result. So and even in terms of our individual projects, it's a big waterfall. We were kind of writing big design documents, 6 months just talking about what we're going to do before any code was written. And then really it dawned on us that we needed to move up a level. We need to get at least to the Stone Age and get some basic tools. So luckily at the time, another part of SAP had been working on something called the Lean Java server. So with an eye to the future, instead of having our big old monolithic Java EE server, there was this much more modular OSGI Equinox-based server that was, say, very modular, very lightweight, and then easy to add things in. So it wasn't really bringing the whole Java EE stack with it. But we did have Tomcat 7 in there, Spring. It was using a lot more modern technologies. Interestingly, in terms of what we were doing for the ID service, we're using the SAML protocol for single sign-on. That's something SAP was offering in one of its other products, so we could just lift that in. And we really kind of took the break away from SQL at this point as well. We already had 2 million users at the time in an existing LDAP server, Novell eDirectory. And we decided to introduce MongoDB to start doing things like cluster-wide session support and just getting into some of the more NoSQL stuff. Interestingly, our roadmap for the next year or so is actually to move away from MongoDB, not so much because there's anything wrong with it, but because of our SAP runs SAP philosophy, and because we've got this great new database technology, then obviously we'll be moving on to the SAP HANA database. Again, to become a good reference customer for ourselves and show what that can do. In terms of the actual tools, then, yeah, we stayed with our issue tracking software. Jira does a fine job for us. Similarly, Bamboo. So, yeah, both Atlassian products work very well. We stayed, for the time being, with Perforce. That's our corporate standard for source control at the time. And we stayed with Eclipse for an IDE, and we'd already been using Ant and Ivy for our build and dependency management. So we had a little bit of a leap onto a few more modern things, getting rid of the old out-of support stuff, just making life really a bit easier for us as developers. So then we took things up a gear again. My manager, a very enlightened guy, started reading about the DevOps movement. And we got hold of the book, the Continuous Delivery book, from Jez Humble, the ThoughtWorks guys. And yeah, everyone on our team got given a copy of this book. And if you haven't read it, I highly recommend it. It's basically the Bible of how to do continuous delivery. And it's nicely written. There's a few examples in there, but it's not really tied to any one technology, but it's all of the principles that you need. What it boils down to is everything goes under version control and everything is automated, everything is scripted. And the idea is that all of those scripts are then also under version control. And that gives you really good repeatability. In our case, we started working with that on top of our own cloud, basically a sort of vSphere kind of landscape. And we use Chef a lot, which you'll see in the next few slides, to actually do some of the building of those machines. So yeah, virtualization is quite key to this. It helps, if you want to sort of do continuous delivery, have a check-in that gets built, deployed to QA, ultimately get deployed to production. One thing that makes that handy is to be able to just spin up and spin down machines at will. The other great thing for us was instead of having to wait 3 months for new hardware, all we needed was access to a big VM system. And an individual developer could ask the ops guys, and they would create him a VM, and he's got somewhere to work, and that's in a matter of hours. Chef is quite easy to use. So the process at the time, it's not fully scripted at the developer level. So the developer would get his VM, it'd be fairly raw Red Hat. He would then go and install the Chef client software on it, get that to talk to the team's Chef server. And Chef server contains all of these recipes and things, and you can sort of drag and drop the recipes onto your node, run this Chef client, and it'll basically go and build you your server from scratch, installing Apache, Java, and so on. So that's an example of the Chef server screen itself. It's all web-based. You can see we're editing a particular node that would correspond to the developer's machine. It's maybe a little bit small for you to see, but you've got these recipes and roles on the left-hand side, and the node that you're editing is on the right-hand side. It has this run list, and you literally just drag and drop these items across. So you have recipes for install Apache, install Java, install MongoDB, And it is as easy as drag and drop, drag and drop, drag and drop, go onto that system, run chef client, wait 10 minutes, and it will just run all of these scripts and build you up your environment in a completely repeatable way. And in fact, one of the things I'm doing as a bit of a Friday afternoon project at the moment, as well as the servers themselves, we're starting to look at applying this to developer workstations too. So when a new developer comes onto the team, all he needs to do is have Chef Client on his laptop, maybe run up something on VirtualBox, and we can spin up a development VM on his laptop that will then install Eclipse. It will connect to the source code repository, install all the other useful tools. So he's not having to fish around for all of the software to install. He can just drag and drop developer role, hit a couple of commands, wait 10 minutes, and he's got a fully set up and configured developer workstation. In terms of how Chef itself works, can everyone read that text okay, or is that a bit small? Yeah, people are nodding, that's good. So Chef mostly is layered on top of Ruby. So what you see there is just standard Ruby with the Chef DSL as some calls. So you can see, that's the first part of the recipe. Seeing, is this Red Hat or not? If so, do a couple of tweaks. Set the version of Apache to install. Then create the actual installation folder for Apache. And you can see, instead of actually running a shell script, which would be one way of achieving the same thing, it's using this abstraction layer. So it uses this DSL item directory to create a directory instead. Now, the power of that is that if you write a Chef script correctly, it will run on multiple platforms. So that same script could run on Windows just as easily as it could on OS X or on Red Hat. So you get a lot of power to actually change the platform that you're running on quite quickly. So that's the actual initial automation of the server creation. Then we started thinking about automated testing as well. Essentially it was a bit embarrassing to be in 2010, early 2011, to be a team that really had a number of unit tests you could count on the fingers of one hand. We had very poor coverage. The QA guys, they'd recorded a few things in some of the Mercury tools and it's covered some of the very high level cases, but there's no real detailed testing of the functionality. It was just a smoke test to make sure it wasn't obviously broken. That obviously led to problems, a lot of frustration. Would release something into production. The poor guys in QA couldn't quite get all the coverage. Some bug would crop up, an exec would complain, would be up late. Nightmare. So we took a step in the right direction there as well. We started the initial bit of automated testing. Really, it's almost behavioral testing, really, by using Selenium, the tool from ThoughtWorks, means that you can actually record scripts in the browser. You can check that the browser flow is doing what you expect. That can be played back. Most importantly, the Selenium tests can be replayed from JUnit. Then that can be built into the build, so that before QA even get to look at the system, you've got a whole bunch of tests that have been run before you're even going to try and deploy it somewhere. That was one thing that probably cut the QA cycle in half from a week to just a few days.
Excuse me, I have a question.
Yeah.
You have a point, developers get feedback in minutes. What do you use as a feedback? Mail, Twitter, monitor on the wall?
Right, so the question is, developers get feedback in minutes. What do we use for that? The main feedback they get is they will run the build scripts. They'll run the ant command, and then it will get to the end, and it will just say success or fail. And if it fails, it will say these tests failed. So it's nothing as fancy, even as email. It's just seeing the result of the command. Similarly, when that build is run by Bamboo on the continuous integration server, that will send an email to them to tell success or failure as well. But ideally, it shouldn't get to that point. So that's just a quick look at the Selenium IDE. It works as a browser plugin. You can just hit the record button. Again, the text may be a little bit small there, but it's saying, open this path, click and wait, type this into the password field, type this into the user field, click submit, wait to see what happens, standard kind of test script stuff. And yeah, that's easy to build into the automated build pipeline because you can run the whole thing just from a single line of Java. But even so with this, it's still, things are getting quite nicely scripted, but it's a whole bunch of scripts that you have to learn how to run. So on the basis of, automate everything, script everything, put it into source control, one of the guys on our team wrote a tool called Cocktail, which essentially is he just pulled together all of these steps into one master script. And that means that he even had this thing, so it was scripted to talk to vSphere. It could actually script creating a VM. It could then install and run Chef Client, do some initial tests, deploy the software, run Selenium. So that really took us almost all the way to actually having proper continuous delivery. It reduced to just 4 or 5 commands to type to create the entire landscape for QA or production in a multi-server landscape. So that was our first year, really, of going from very primitive tools and background to actually having this cycle where we're using Bamboo, Cocktail, spinning things up on vSphere, building them with Chef, deploying, automated testing with Selenium, good feedback loop, lots of automation. So then we started to refine this and start to introduce the next level of tools. So the one thing that we did, Perforce is, as centralized version control systems go, it's one of the best out there, nothing wrong with it. But we began to experiment a lot more with Git. And in fact, in the early days, individual developers were using Git and using a bridge to Perforce. So they could actually do lots of branching themselves and then just get the branch back together and put it into Perforce. And then we realized that we could just get hold of GitHub Enterprise and just have all of that power without involving the central system at all. The way in which we use Git is worth mentioning. So as you may be aware, Git really allows a lot of branching and merging. It kind of thrives on that. But we have almost an opposing principle that the central repository, as much as possible, should represent just one linear series of commits. So it's really clear what's happening in what order. And how we manage that is at the developer level, people can create as many feature branches as they like, but then the developer is responsible for doing the merge back into the main line on their own repo, and then they push the result of that back into the central repo. So there's only ever one branch in the central repo. Not too much more to say on that. But then, yeah, this is probably the thing that's made one of the biggest differences to how we work, is getting into proper behavior-driven testing with Cucumber as a tool. There's actually very good Java support for Cucumber now. There's a half-decent Eclipse plugin where you can click on a line of Gherkin, press F3, and it will take you to the relevant line of code. But what's important about this is, well, how many of you have heard of Cucumber? Almost everyone. That's amazing. Compared to 6 months ago when I asked the same question, it was probably about a quarter of the people there. So yeah, as you all know, if you've ever seen Matt Wynn's talk on mortgage-driven development, which is fantastic, the idea is to develop Gherkin scripts that you can discuss with the business. That's one of the most important things, where we are a long way from perfection with that. A lot of our scripts do look very mortgage-driven, very technical, but our aim is to try and make them look like this. So you can read that to a business person, they can say, yeah, they're trying to get into this particular SAP site, they want to log in, and then they should get to where they want to go. So you can actually discuss that almost, to a business person, they see that as really technical specification, but at the level that's within their grasp. So it gives them buy-in to what you're doing. To the programmer, this is the cool part, is every individual line of that gherkin pattern matches to a regular expression in an annotation on a Java method. So in other words, every line maps to one method. That is a very simple case that you see there. It's just matching the entire string. But any bit of regular expression you put in brackets, it can parse out and pass in as a parameter to that method as well. So you can actually start to build up a bit of a library of these steps with parameters that are reusable. And that essentially boils down to, as you can see there, it's doing some HTML unit type stuff, but that's just going into sort of your standard unit testing kind of code. So it really gives you this bridge between the developers and the business where you're doing test-driven development, but the business only sees the description in their language, and it's all tied together. Who writes the specs? Very good question. Who should write the specs in an agile setup is usually the product owner in conjunction with the QA guys. How we are working at the moment, what tends to happen is the backlog items, they're written in kind of cucumber-ish by the product owner. So he uses the general flavor of given, when, then, when he's describing a user story. And then the developer usually translates that into actual gherkin. But part of our process is that whenever a developer checks in any commit, what they have to do, as well as mentioning the user story that it's about, they have to include a link to the Cucumber feature for that commit as well. So then the QA team, they see the commit, and then they can see the Cucumber that it links to. So we do have a feedback loop all the way around.
Can you say something about how you manage all the gherkin requirements?
How we manage all the gherkin requirements? We have at the moment around 600 scenarios composed of about 6,000 steps in total. We do have work that we need to do. At the feature file level, it's not too bad. It's more or less a directory structure of feature files broadly organized by business function. The real challenge is trying to avoid having the unit test code mapping onto exactly the same structure. There's a real temptation to say, well, here's where all the lines of gherkin are. We'll have a Java file behind that with one method for each line of gherkin, and then the Java file maps to the feature file. That's not the best way to do it. The best way to do it is to develop an independent model of the steps, and then you can compose steps from that model to match the gherkin. We're having trouble doing that, I'll be honest. We're learning as we go, but yeah, we've not been doing it all that long. But it's quite an important point. Again, I really encourage people to go out and see Matt Wynn's talks on this sort of thing. It's a good guide as to how to do things better. So yeah, having got to the end of year one, thinking we're doing quite well, the theme you'll see coming back to this a lot is continuous improvement, not just continuous delivery. So our team member who wrote the cocktail tool decided he had to ratchet it up one more level and produced a tool called Barkeeper, which goes much, much further. So as well as being this command line tool that can be scripted to create the VMs on vSphere, it manages everything. Before, we could use the tool and just script it to say, cocktail, create me a VM over here, deploy over there, and we'd have a script of a few lines. Now we actually have almost a metadata file for each project. So the entire project, like our SAP ID Service project, across development, QA, and production, all of that landscape is described in one text file, which is under source control. And then that can be change controlled, automated deployment all the way through. You'll see on the next few slides how that all works. So this is the example of the part of the landscape definition. You can see there it's just describing the production and test parts of the landscape. The developer and QA bits are very similar. So at the top we have the description there. It's got the repository location where everything is stored for the project, which of our cloud providers can be used, so that the tool is being developed so it can work with other cloud providers, Amazon, vSphere, all the others. What the basic operating system template that we're using is, in this case, Red Hat 5. And then you can start to see how some of the Chef stuff comes in. So we're saying that these machines will all be bootstrapped using the Monsoon recipe that we've defined in Chef. In the case of test, that will be done using one set of recipes. In terms of production, a similar but slightly different set of recipes. So we can control all of these slight differences and all the similarities across the landscape, but without having to do that as a manual operation through a web UI. It's just all in a file that's version controlled. So that's a sample of, drill down and looking at the production landscape, and the Barkeeper web UI based on that metadata will show us these are the actual servers at the moment. The green dots there show that all the servers are currently running, and the icons actually allow operator control to reboot individual servers or do a chef run on each of them. So as well as actually running a deploy across the whole landscape, we also have more fine-grained control where we can do things to individual servers at an operations level. The other really cool thing that we get from the same technology now is having the whole landscape in a file and the Barkeeper tool to control all the VM landscapes. It means that one developer can switch between different projects, and when that developer goes to a new project, he can go into Barkeeper, log in, and say, I want a private bar, so I'm on this new project, just on the drop-down list, select it, click run, and it will then go and build him his own landscape of servers as a developer that he can use. And that takes minutes to spin up database server, application server, whatever needs to be there. And the other thing we've done is addressing how we use Chef as well. It was a bit kind of Wild West in the early days. Everyone was writing recipes, people were changing other people's recipes, and what you would find is someone edited a recipe that was being used by someone else in production, and suddenly it fell over for no reason that the original developer could control. So what we've done now is introduce this notion of a centralized cookbook repository, where the central library is much more tightly controlled, and people know that any changes they make there will affect everything. And then each project has its own local cookbooks where it can almost use like an inheritance mechanism to write the specializations that work just for their project that won't mess up anyone else's work. So next it's on to the real nitty-gritty of our actual pipeline. And these are all of the steps in Bamboo that are used to get us from a developer check-in to a QA deployment. And in fact, a production deployment, as you can see from the grey boxes at the end, they're just disabled. But when we want to go to production, we just enable those and run the same pipeline, and it goes all the way through. So to go in a little bit of detail on that, the first stage just runs the build. So we run Maven now. We've evolved from Ant and Ivy. We use Maven largely because as an OSGI shop, if you want to do automated build of OSGI artifacts, Maven's pretty much the only way to do it at the moment. So it runs the Maven build, creates all the artifacts, puts them into the Nexus repository, synchronizes all of the chef recipes out from the GitHub, and then does a deploy of that release onto the development landscape. All of that takes about 3 or 4 minutes. The next, probably the most important part, is to run all of the automated tests. So as I said earlier, each of those blobs there is a test suite. There's about 600 scenarios in all. As you can see on the right-hand side, there's UI test suite 2, 3, 4, and 5. And they've been split up for performance reasons, and I'll address that in a couple of minutes. So once we've run all of the tests on dev, we've got a reasonable amount of confidence. So now we can actually deploy this to the QA and staging and test systems. They're all essentially the same level of trusted systems by other people. So, our project is for logging into any SAP website. So other parts of SAP want to use our system to develop their systems. So that's where these come in. The test thing there is the one that other projects use for their development. And they deploy to the green systems. So we have the concept of green-blue deployment. For an ID service that supports the whole company and up to 1 billion users, we can't afford any downtime for a deployment. So what we do is we deploy everything to the green pool of servers, which is inactive. Then we can run the whole test suite against those, in this case a read-only test suite that doesn't interfere with the database too much. Once we've got a reasonable amount of confidence that that's okay, we can then make the green systems active and think about deploying to the blue systems. Then finally, we've got the confidence and we can deploy to the blue systems as well. So this thing about splitting up all of the UI tests really gives one of the most important lessons in continuous delivery, which is fast feedback to a developer is absolutely critical. The developer needs to know whether he's made a mistake within minutes. Ideally within 10 minutes for building on their own workstation and getting all the local tests passing. And in our case, our target time for a full deployment out to QA, possibly to production, is a maximum of 30 minutes. That's why those tests get split up, because when you've got 600 tests, most of which are scripting a browser, they can take a few seconds each. And suddenly it's very easy to have all of your tests running linearly and taking an hour or more because they're scripting loads of browsers. So the important thing of having a cloud is really start to embrace parallelism. You spin up as many instances as you need for the short amount of time, and then you parallelize out. So whenever we see any test suite exceeding 3 minutes, we split it up and make it into 2 suites that run in less than 3 minutes. And if necessary, we add another core or another server to the thing that's running the tests. So to run all of the tests typically takes 5 or 6 minutes with the level of parallelism we have. One of the nice things about running in Bamboo is you get the graphs like you see on the right-hand side. So you can see there, we're hovering, at worst case, around 35 minutes if the servers are busy, but usually around 30 minutes or so for the entire build. And because we're always able to see, the developer, when they check in, they're monitoring the build, seeing how it's running, they're always going to see that graph, they're always going to see the last sort of 30 or so builds, and they can see if it's starting to get worse or if it's starting to get better. So when we have a performance problem, visualization of that is important, and then coming back and doing something about it. So in terms of the technology and what we've done, if any of you are trying to convince your management that continuous delivery is a good thing to be doing, this is what we've found in the changes over the last couple of years, is that we've gone from monthly releases, which most places would probably consider quite good, to on average releasing about twice a week now, to the degree that it just becomes a non-event. Or if we want to go to production, we send a quick email around the guys to say, make sure you're not doing anything too experimental that you're not happy with going to production. Everyone agrees, maybe it takes half a day for everything to just commit something they're happy with, and then we'll do a build and it gets deployed. Sorry, yeah.
Since this service is used by all other SAP products, how do you you ever do anything not backwards compatible, or how do you handle the impact of all the rest of the stuff if you do a change? Because, I mean, you can't just roll that out.
So the question is, do we do this in all the other SAP products, and how do we manage backward compatibility? At the moment, this is something we only do within a certain area of the IT department for primarily our web-focused products. But as we move more and more to the cloud, then what is now the web and what will be a cloud product becomes essentially the same thing. So it's not necessarily used for the on-premise software that ships as a pile of DVDs like this, but for all of the stuff that is used primarily via the web, then yes, we do this. And in fact, the SAP ID service itself is becoming an SAP product from sometime this year. So we've actually evolved from doing websites to actually helping build products for the company. So it's another area actually where the IT department is contributing revenue back to the company. Yeah.
Do you work anything with outsourcing, for instance, to India or developers in India?
So the question is, do we do anything with outsourcing, for example, developers in India? Not to India, although our team member in Russia is from an outsourced company. But yeah, my own experience, not necessarily within SAP, but within other companies of outsourcing, is that keeping team members within a few hours of each other in terms of time zone is fairly important. So distributed working, the distance isn't so much a problem, but the time can be. The problem I had working with colleagues in Malaysia, for example, is that they were really good colleagues, but I'd try and pass a piece of work over to them before I went home, and then I get in the next morning, and the first thing I'm getting back is a question, which means that they've wasted half of their day waiting for the answer to my question. So yeah, my experience of working with places like Malaysia and India is it typically works best when you can put a whole package of work together that can be clearly defined and handed over. When you're trying to work as more of a tight-knit team, you need to be within a few hours of each other in terms of time zone. So yeah, that QA cycle, because that's all now automated tests, it really is, pretty much only the automated tests. When we do a release to production, the QA guys will basically just have a quick play, look at maybe the most critical bug fixes and check that they're really fixed, and that's it. You can go to production with no fuss in a few hours. Best thing of all is because we've got this green-blue deployment and the ability to really rapidly switch to the previous release or even just deploy a previous release. If there is some big bug that crops up in production, some showstopper, it used to be that there'd be phone calls from people with C and V in their titles and being up all night and rings under the eyes, panic, not good. Quality of life as a developer with this technology is amazingly better, because if anything like that happens, you can just log in, switch to the last known good setting, and then go to sleep, wake up refreshed the next day and actually work on the problem properly. And that usually means that problem gets fixed better and sooner as well. I was saying earlier on about the hardware delay taking 6 months and the whole approach to writing design documents, there's really long lead times. Now with something like Barkeeper and describing an entire landscape in a text file, it means someone's got an idea for a new product. They can just describe that landscape, put it into source control, hit run on Barkeeper, and they've got development, QA, production landscape set up, ready to run, just with a couple of servers each, and then they can start to try things out and actually demonstrate it to people. If an executive sees it and likes it and asks when can it go live, it effectively already is. So it's given us really great power to do rapid innovation. And obviously that leads to people in the business being much happier and developers being much happier. So that's not quite the end of the story, because what I've been talking about so far has been mostly on the technology side. But the other thing that we found really made a difference, particularly in the last year or so, was actually what we did to the team. So, as I said to start with, we were doing waterfallish. Then we said, hey, let's do Scrum. Everyone knew what Scrum was because they'd read the web. It turns out that's not Scrum, that's Scrumish. That means that you're just having a stand-up meeting every day and otherwise generally not doing things right. The real difference came when we actually invested in getting a Scrum trainer and actually really getting the team into what's not doing Scrum in terms of the ceremonies, but understanding why those ceremonies are there, understanding that the whole purpose of Agile and Scrum is having this culture of always improving yourselves and improving what you're doing. So yeah, we all went to Berlin for a week, except one guy who couldn't make it. He had to stay in London, he had a passport issue. And even that worked well, because as a distributed team, it meant that we were able to practice working in distributed mode. So we were doing these exercises on the Agile course, and we had to have a product owner. So our product owner was actually this guy in London who was on a laptop screen via Skype. And it really simulated very well what our daily work is like. So it was a very good way to do that particular piece of training. So yeah, it's really transforming, upgrading the minds of the team is just as important as upgrading the tools and technology that you live with. So yeah, and now we're moving on. We've not stopped. We're using Gerrit recently for code review. That's proving very useful, getting unexpected benefits from that. It's not just review to check that the style is right, but we're finding that people are communicating a lot better and actually using Gerrit as a tool to send each other patches as well. It's a very interesting way to work. And also we're playing with Pomodoro technique, so just doing everything in 25-minute chunks, and finding that's working for us too. So I've just run slightly over by a couple of minutes. Apologies for that. But thank you very much. Are there any more questions? No? Test data strategy. Yeah, that's again something that's scripted. So the dev system where all of the tests are run, that's essentially torn down and rebuilt from scratch each time, and that includes seeding the database with appropriate test data. And also a lot of the Cucumber scripts create their own test data as a side effect. So it'll stay, given that I'm a user who needs to log in, and that will actually map to a step that says, okay, well, I need to create a user with an email and a password. The other thing that's helped us there is when it comes to sending an email out from the system, we intercept any emails that go to example.com and actually use a little private webmail application within the system itself, so we can then easily test the result of clicking on a link in an email, for example. Yeah.
You haven't said much about unit testing.
I haven't said much about unit testing. There's a good reason for that. We focused on going from the outside in. So we really adopted behavior-driven testing first to get the confidence that the system behaved as we wanted it to behave. And in fact, really just in the last couple of retrospectives, we've decided as a team that we now need to start doing a lot more unit-level testing. We've reached a level of maturity with the behavior-level stuff, and now we need to start doing unit stuff as well. So yeah, it's largely because we haven't really done it, but we're starting to. Yeah.
As a follow-up on that, do you find a lot of issues that drive you to do unit testing if you have a good coverage with the behavior-driven testing?
Actually, I mean, one of the reasons we've been late to doing unit testing is we've actually found the behavior-driven stuff tends to do the job. In particular, if a bug crops up, one of the first reactions to doing a bug is to write a behavior-driven test that captures that case. And then we see that test fail, and then we fix it. So we actually find that by working at the behavior-driven level, it almost eliminates the need for unit testing. Having said that, I think the benefit of getting into unit testing more is that changes how you write your code to make it testable, and that in itself leads to better code. So that's one reason why we're investigating that. Yeah, sorry.
Yeah, I was wondering, all these tests that you said were very important to running in parallel, but I guess they're hitting a database. How do you solve the problem of writing and reading conflicting data if they run in parallel?
Yeah. So the question is, when we're running parallel tests, how we avoid conflicts in the database. Really, it's the answer that I gave to the other question, which is around test data. So any data that's preloaded into the database is only used to drive read-only tests. Anything that's a read-write test, it creates its own data as part of the test. So then there's no overlap between the cases. Yeah.
And your sheet recipes are, and landscape are pretty controlled. What if any project needs another thing? Can they put it another Java version or another tool? How do you manage that?
Yeah, I think that's where the inheritance side of things comes in. So people can take the centrally stored cookbook, bring it into their project and say, I want to override these parts. Chef makes that fairly easy. You can provide attributes that then drive behavior. So there may be an attribute that is the version number of Java you want to use. So you could say, well, we'll use the central Java recipe, but in our project, we'll override the attribute 7 to be 6. Any more questions? Okay, well, thank you very much. It's been a pleasure to talk to you.